Alright, so in this video I'm just going to give you a super quick overview of some of the original setup as well as some basic syntax of SageMath. So SageMath is actually this awesome free open source mathematical software system. Its syntax is actually Python based, so if you've done a little bit of programming, then writing code in SageMath is super easy. Also, since it's open source, there may be a few weird little changes and hiccups that may occur, so if anything actually happens in the kind of changing to CoCalc or anything like this, let me know right away so I can incorporate anything that's new or changed along the way. So in this case, there's actually going to be two different ways that you can actually interact with SageMath. One of which is actually to download SageMath directly onto your computer and then run it through the command line. Or you can actually run it through the SageMath cloud. And that's actually what we're going to be doing in this course. So the original way that you're actually going to access SageMath is going to be by going to www.sagemath.org, and then you're going to go to this page. Or at least on the day that I accessed it, this page looks like this. What we're going to be going into is going to be this world of SageMath Cloud. And it recently changed the name to CoCalc, so that's why you're going to be seeing some weird just changes that occur to this thing as it continues to evolve and gain some traction and things like that. So in this case, if I click into that first little bit, you're going to be brought to another screen. In this case, there's going to be a little bit of kind of overview videos that they've actually produced. So if you're interested in learning a little bit more, they have gobs and gobs of extra information available for you to look at. What you're going to want to do in this case, you're going to want to go ahead and actually create your free account. All it takes is just a name and an email address, so it's really quick to create, and you're going to want to do that to be able to easily store some of the course information as well as access some of the things that I'm going to be posting. So in this case, once you've actually created your account, you can go ahead and actually sign in. So in this case, the sign-in page is going to look something like this, and it's actually going to be found at cocalc.com. So once you've actually created your account, this is going to be the thing you're going to want to bookmark or favorite or however you store your commonly accessed sites. So in this case, my email address is mark.spanier@dsu.edu. I'm going to sign into this thing, which is going to bring me to my main little page. So I actually have a couple different classes that I use SageMath in, so you can see some of them down below. I actually use it in my calculus class, my operations research course, and then in this case, in my Math 201 course as well. What you can do in this case, you're going to be creating new projects. So if you create a new project, there's going to be a bunch of small little projects that exist underneath this thing. So if I just go ahead and call this thing a test project, and I got my cap lock on, so test, I'm just going to create this thing, and it's going to give me a new little project. If I click into this thing, it's going to bring me to this little page, which has no files inside of it. What I can do in this case is I can create a new file. So this is going to be a new little workbook if you want to think about it. I can do a whole bunch of stuff inside of this individual file. So if I want to call this, section 1.1 or section 2.2 or homework 1 or homework 7 or whatever it ends up being, if you want to stuff all of those things into a nice little worksheet, that's exactly what you're going to do in this case. So if I do new, I'm going to give this thing a name. So let's call this thing, I don't know, homework 0. Just to give us something to work with. I'm going to be creating a Sage worksheet. You can see that there's a couple other things you can actually compute and do in this world as well. For those of you that know a little bit of LaTeX, you can actually incorporate those two things together, which is a really, really slick thing to do. But for right now, I'm just going to be working in the world of Sage. So I'm going to click that thing, and it's going to think just a little bit to load to create everything and go from there. Again, it's done on the cloud, so sometimes it can take a little bit to get everything up and running, and then you're going to see a screen that looks something like this. So in this case, there's nothing on this thing. As you go through some of the things on D2L, I'm actually going to be giving you some of the documentation. So if you click it, it'll already be a screen that's already set and ready to work with. But if you want to just play around with on your own, you can just open up one of these brand new blank things and then start typing things as you would normally. So in this world, it is first and foremost some mathematics software, so you can do basic math operations. For example, if you wanted to do 3 multiplied by 5, so 3 and then this little star with a 5, and let's see if I can make that a little bit bigger so you can actually see. Okay, so 3 times top 5, and if you were to simply just hit enter, nothing is actually going to happen in that case. It's just going to go to the next line. So if you actually want to make this system do something, you have to hit this little run button. So if you hit this little play, it's actually going to do the computation of taking 3 multiplied by 5. The first operation that you do on one of these workbooks does take a little bit to actually get it all set up. This is the kind of initiating the conversation that it's going to be having with the server. Once you've actually made that setup, it does actually end up working pretty quickly. There are times that if there's a bunch of people on the server, it actually does take a little bit. But now you can see that I've done that first operation, which seemed to take a very, very long time. But if you go back now and take, let's say, 5 times 7, it'll actually be done really quickly. So it takes that first little bit to get everything initiated, and then once you have all of that, the whole process becomes pretty slick and pretty quick. So you can see in this case that it's actually chunking this thing into a couple different little bins. This little world is all going to be executed at the same time, and then this little world would all be executed at the same time. So if I wanted to do a couple lines of computations, let's say 3 times 5, and then if I wanted to take 7 times, 17, and then if I wanted to take 120 multiplied by 91, I could do all 3 of those things by hitting this single run command at once. And it's going to do those 3 separate multiplications. So you can group things together as you'd like to see fit, or you can do things one at a time. It doesn't really matter how you organize some of those things as well. Another way that you can actually make this system actually run in this case, rather than having to take your cursor and move it up to the run command, is actually to go into one of these little cells, type in what you're going to do. So let's say 8 times 9. And then instead of hitting enter, you're going to hit shift and then enter, which is actually going to make that computation work as well. So it takes a little bit of kind of getting used to how to move things around, but once you've played with it a little bit, it's actually pretty easy to navigate and move some of these things around as well. Obviously, this system is going to have way cooler stuff than just simply doing multiplication of things. There's gobs and gobs of things you can do. Some of it's actually going to be coded into it as well. You can see, there's a giant tab all about calculus, which is going to have all the calculus operators. There's some linear algebra operator. There's some general number theory operators. And we're actually going to be playing with some of these ones as the course goes on. There's going to be factoring, there's going to be prime numbers, there's going to be modular arithmetic, there's going to be all of this stuff that you can kind of see in there as we go throughout the course. So the one that's really important right away is actually going to be this notion of prime and factorization. So we actually have the ability to factor things by simply typing in the word factor. So if I took factor and let's say I put the number 15, it'll actually factor that thing into a 3 and a 5. As we're going to be chatting about later in the course, this world of factoring is actually really, really hard. It is one of these things that factoring 15 is actually a really easy thing to do, but the moment that this little number right here becomes a product of 2 gigantic prime numbers, the actually factorization of that thing becomes very, very challenging. That's actually one of the big key instances that makes RSA really, really secure, is that factorization is really challenging. But in this case, if I have 2 small numbers, it does factor pretty quickly as well. So you can see that factoring 15 takes essentially no time at all. You can also do this test on whether or not some of these numbers are going to be prime. So this is going to be the command of isPrime. And if I put the number 15 into that thing, it's going to kick out a false because that thing is not actually a prime number. Whereas if I put, let's say, 7, I know that 7 is going to be a prime number, so it's going to kick out true. So it's going to kick out this nice little Boolean expression of false if it's actually not a prime number, and true if it is in fact a prime number. So in this case, we're going to be chatting about a few other primality tests as we go throughout the course. There's some built-in commands to this thing that we don't actually know what it's doing. So there's the idea of what system is it actually doing to determine whether or not 15 is prime. We're going to be chatting a little bit more about ways that we can actually start to see some of these numbers being prime or not. There's going to be some very inefficient algorithms and then a few that are going to be a bit more efficient. But it is kind of this nice thing to see that it does have some built-in capabilities as well as creating some of them on our own. One of the slightly annoying things that have changed in the most recent update of this world is actually in the world of sharing some of these things through an actual website. So if you have one of these documents, and if I go back to my files page, what I've done for a bunch of our documents is I've actually shared this thing. So if you click this little share icon, and if I try to make this thing public, it's going to give me a little link. So those little links are going to be the things that you're going to see all throughout D2L, sprinkled throughout those items that are going to give you access to different types of things. If you click on one of those, so if I click on the one that I first created, which was my statements 1.11, it's going to bring you to a page that looks like this, which looks very similar to what we were just looking at, except for it's actually not interactable. I can't do anything with these things. It's just a simple printout of what that worksheet looks like. So what you got to do to actually make this do something is you actually have to open it up inside of CoCalc. So previously what it used to do is it let you used to do this as a guest. You did not actually have to make an account. It would bring you to this little page and you could change everything up that you wanted to. What it does now is it actually brings you to a page that looks like it's one of these things, but again, I can't actually change anything. It just looks nice in this case. But if I were to actually change some of these numbers, I couldn't actually re-execute any of these things. And that becomes problematic when I want to try to change some of these things up, or I'm going to give you some code that you're going to want to make just small edits to, and then go ahead from there. So what you can do in this case is that if you sign in actually to your CoCalc site, what it's going to do is that it's going to open it then up as an actually executable document. So if I take this link, and if I go back to my page that I was actually signed in on, so let's just open up a new tab. So I'm not in the incognito window. What's going to happen is that if I open this thing up in CoCalc, now it's actually going to bring me to my page because I'm signed in. So you see that little blip. And now it's at a page that I can take these documentations, I can change these numbers up. So originally I had the number 3 and 7, and if I multiply those things, but now I can actually change the 7 into an 11, and it's actually going to re-execute. So that's the one weird little hiccup that actually just kind of happened in the last couple of months. Be aware that it is free software, so some of these things are going to change and manifest and kind of modify as we go throughout the entire course. So again, if any of that kind of awkwardness happens, you're like, oh, I opened up the document, but I can't actually do anything with it, let me know right away. I can easily record something or give you access to some of these documents in a different way. So it's just kind of be aware that as the system is evolving and things like that, it is still kind of in its early stages for being this shareable documentation and things like that. Some of that stuff will actually happen. So this is actually the page of statement 1.1, which you'll see in that very first section of this course. There's going to be, again, some of these nice commands on whether or not something is prime, as well as the chatting about how to factor some of these things. So if I take the number 21, we know that it factors as a 3 and a 7. If I take the number 15, you can see that I can actually identify it as a variable. So I can set that thing to be an n, and then after that I can run the isPrime command on n. What's nice about that is that if I run it the first time, I can then change that 15 into a 17, and I don't have to change it in 2 spots. So this world of creating variables is going to be a really nice thing that I can use this value of n everywhere that I want to. I don't have to go through and change that little n into a 17 over and over and over and over again. I can also list a whole bunch of integers. This is going to be a really important thing as I start making some of these loops. If I'm wanting to cycle through all possible integers between, let's say, 2 and 20, I can make that little list from 2 up to 20. In this case, it's going to be including the 2 as well as the 20. If I want to talk about all the prime numbers between 2 and 20, I can print these out with the command of prime range. So in this case, it's going to start at 2, and then 3, and then 5, and then 7, 11, 13, 17, and 19. And then I can start looking at some of these little lists that we were trying to build these things up to build up some counter examples. So again, let's make this just a little bit bigger in this case. So if I look at this list of taking all of my primes between 2 and 50 in this case, if I compute that expression that says 2 to the n minus 1, this is the one that appeared to be prime for a little while, but then at some point in time it does break down. So in this case, what's going to happen is that it's going to loop from that first number 2 all the way up to that last prime in that little list, which is going to go all the way up to a 47. So in this case, we know that the number 50 is not prime, so it's going to be stopping somewhere before there, and in this case, it's going to stop at the number 47. So in this case, what's happening is that it's going to print out this little triplet. The first number is going to be the number n, which is going to be that prime number that I'm looking for. The middle number is going to be that expression of 2 raised to that number minus 1, and then it's in that simple little command of, is that number actually prime, yes or no? So in this case, the first one being 2, the middle part's going to print out 2 raised to the 2, which is a 4, minus 1, which is going to be a 3. In that case, I know that that number is prime. Likewise, if I take the number 3, it's going to take 2 raised to the 3, which is 8, and then subtracting 1 from that thing, which is going to give me down to a value of 7, and I know that that number is also prime. If I take 5, which you can see I've skipped the 4 because I'm only cycling through things that are prime, I'm going to take 2 to the 4th, which is 32, subtract 1 from that thing to give me 31, and again, that thing is going to be prime, and I can keep on doing this thing all the way until I get to that value of 11, which we now know is if I take 2 to the 11th and then subtract 1 from that thing is going to be not prime. And a way that I can actually test for that is I could actually go ahead and factor that thing. So if I take 2047, I know how to factor that thing. It's going to factor as a 23 times 89. So it's this slick little thing to see this Boolean expression that's going to kick out, hey, that thing is not prime. And if I actually want to know what the factorization is, I can go ahead and actually just factor that thing. In this case, it's going to kick out a 23 times an 89. And we're going to be chatting a little bit more about this world of how do we represent some of this factorization later in this course. There's going to be this nice fundamental theorem of arithmetic that gives us this unique factorization of some of these numbers as long as I organize these things nicely. But for now, it's going to just be a little bit of, hey, this is going to be coming down the pipeline. We'll see some of these things later. So the other example that we saw was this one that we're going to take this little loop and it's going to run from 1 up to 50 in this case. And I was looking at that expression of n squared minus n plus 41. In that case, it actually ended up being prime a whole bunch of the time until I got all the way down to that value of 41. Once I plugged in 41, I know that that thing kicked out a non-prime object because it actually ended up kicking out the value of 41 squared. So that was one of those examples of, hey, just because you tested a whole bunch of things is not good enough to actually make sure that you've proved this thing. There might be this counterexample lurking way out in the shadows. In this case, it took a little while to actually find it. So you actually do have one of those on your very first homework. I think I gave you the example of, let's say, something like n squared plus n plus 41. So that's, again, going to be one of these things that is going to be not prime, and it takes a little while to actually find the thing that breaks it, but there is going to be one of those expressions that eventually breaks that thing down. So in this case, I just want to kind of reiterate the idea that there's a whole bunch of stuff inside of this SageMath. It takes a little bit to kind of get used to some of the weird syntaxes, especially for some of you that have not done some programming and things like that. It essentially functions like a very basic calculator. It just has some very nice built-in commands that you can do. It's a little bit easier, I think, than working with like a TI-83 or an 89, where you have this horrible little, keypad that you have to type with. In this case, it's much easier to just type it out on your computer and then hit enter and go from there. There's some awkwardness that comes in with it being a free piece of software as well as having to connect to this server, but once you get by some of that kind of awkwardness, it becomes a very, very powerful tool that goes well beyond what we're going to be doing in this course, but it does become this very nice tool that you can keep in your back pocket anytime you want to create some nice little simulations or do some tests on some of these kind of fun little number theory problems as well. So I'll probably end it at that stage. Again, if you have any questions on this software, feel free to let me know. I'm going to give you a bunch of little bonus activities throughout the course that are going to have some of these little commands built into them. So if you're interested in diving a little bit farther into the world of Python and SageMath, it is an awesome opportunity to kind of start to see all of these little pieces combine, this world of math merging with some computer science to really kind of give you some nice counterexamples or to start to see some of the weird structure that these numbers are actually going to be playing.